All right, we're going to start again today on the back page of the notes. And it says, hey, we have a proof here. Where's the error? Well, this one's a pretty straightforward one because we have the given information listed off and it looks like we pasted out the given information correctly. We marked A congruent to D. That looks right. We marked B congruent to E. That looks right. We have B to C and E to F. That's B to C here. That's E to F here. That's the tick mark. So all that information that's given looks correct. But let's take stock of it. What do we have? Well, here's a pair of angles. Here's a pair of angles. And then B to C and E to F, well, that'll be a pair of sides. So if I'm looking at what I want to use, I can't use side angle side because I don't have two pairs of sides and a pair of angles in between them. I've got two pairs of angles and a pair of sides. And if I look at my pair of sides, this would be the included side, but that's not the one that's marked. So the method I would actually use would be angle, angle, side. So that's why it's important to keep track of what information you're using. Now, today, we're going to look at one more method that we have. We're going to look at one more method. And this is in our steps, this is kind of a final step that we have. And it's something that we've actually seen and talked about before. And it's going to be called CPCTC. This is in the second page of your notes here. It stands for corresponding parts of congruent triangles are congruent. It's got a nice long fancy name, but here is all it's saying. All it's saying is what we have talked about before with congruent triangles. When I say triangles are congruent, what do I mean by that? What do I mean? Well, I mean that all of the measurements are the same. So what this idea says is that as soon as I know the triangles are congruent, I now have unlocked 6 new pieces of information that I know. Once I know the triangles are congruent, I have 3 pairs of sides that I automatically know match up with each other. I have 3 pairs of angles that I know match up with each other. So we've actually done this before. Anytime you've listed out, hey, this pair of sides is congruent to this pair of sides from a congruent statement, you've been using CPCTC. When I have congruent triangles, those matching sides and angles, that's where the corresponding parts comes from, those matching sides and angles have to be congruent. So that's all we're saying. So if I ask you to prove, instead of the triangles, if I ask you to prove something about a pair of sides or a pair of angles, then what we can do is we can use this idea, once we get the triangles congruent, to match up those sides and angles. Let me show you what I'm talking about. Okay. So let's say we were doing this proof, and we won't do the whole proof here. I will skip the givens and just point out that the extra information that we can get from this diagram is to say, well, angle MPN is congruent to angle RPQ because vertical angles are congruent. So those are vertical angles, so that gives me my other pair of angles. Therefore, we can make the triangles congruent. Triangle MNP, well, MNP needs to match up with, M matches up with R, N matches up with Q, and P matches up with itself. And that would be, well, we got 2 pairs of angles, side included between them. So it'll be angle, side, angle. Nothing new so far. We've been doing this since before we took the last quiz. So this is nothing new so far. Here's the new part. We're going to say, well, after we know the triangles are congruent, we want to know if angle N is congruent to angle Q. Well, good news, it is. How do I know that? Well, if I look at my congruence statement, remember that I've talked about that congruence statement tells me what's supposed to match up with what. And it tells me N, that second letter, matches up with Q, second letter. Therefore, angle N is congruent to angle Q. So that process I just outlined of looking at that congruence statement, knowing what matches up with what, I need to be able to explain how I can do that. And the way I can do that is by CPCTC. Okay, so that's the new element that we're adding here. Let's do it again. Hey, we should know what we have there. That's a side. That's a common side in both triangles. So we're going to say H to F matches up with itself by the reflexive property. Again, we should be very familiar with doing that. That's nothing new. We have a common side. We're going to match it up by the reflexive property. Therefore, we're going to say triangle EFH is congruent to, let's put that in the correct order. EFH, well, E matched up with G. And then careful because this is a rotation. So F, angle F over here rotates down to angle H down here. So F should go with H and H should go with F. And then what's our method? Well, here's our two angles. Side, not the one included in between them. So this time it's going to be angle, angle, side. There's a great visual of the example of the difference between angle, side, angle, and angle, angle, side. All right, so now that we have that congruence statement, we're looking at this statement, F to G and H to E. Well, let's look at F to G, that is last and first. H to E, last and first, they do match, so we can say that F to G is congruent to H to E based on the congruence statement. And so the abbreviation for that idea, congruence statement unlocks that pair of sides, is that CPCTC. So notice that these come after the triangles get proven congruent. After the triangles get proven congruent. Once I say these triangles are congruent, that unlocks this pair of sides, this pair of angles. And any matching pair of sides or angles will be unlocked through that. All right, so let's try this in an actual proof now. Let's try this in an actual proof. Here we go. So we have our usual given information. And notice that I have my steps written out that I usually have. We have our given information. We're looking at how we're going to use the given information. Then when we're out of givens, we look at the diagram, and then we say the triangles are congruent. And then we have this very last new step at the end, which is CPCTC. You know that we're using CPCTC because of what we're being asked to prove. What we're being asked to prove is not the triangles. But we're going to solve and figure out the triangles first. Then our last step will lead to the CPCTC. All right, so let's walk through this proof because it's a good proof to walk through. Anyways, so we start with B is the midpoint of A to E. So I'm going to say in step one, B is the midpoint of segment A to E. That is given. So we have that given information. Now, that does not say a pair of sides or a pair of angles. That does not automatically tell us segment this is congruent to segment this. So now we need a step 2 to explain how it leads to a pair of sides. Well, let's draw it out. Here's B. Here's A to E. So if B is that midpoint, what does that say about A to E? Well, it says that A to E is getting split into 2 equal pieces. What are those pieces? They're A to B and E to B. So notice that I used the fact that it was a midpoint in order to say that A to B and E to B were the same. So that step 2 came from the fact that it was a midpoint. We looked at a midpoint. Oh, what is a midpoint? It splits it into 2 equal pieces. So I used that to figure out what the midpoint told me. All right, so now we have used this piece of information and we've gotten a side out of it. Now I can put side because I've said segment this is congruent to segment this. All right, step 3. Step 3 is going to be simple. We've got a piece of given information that we haven't used yet. Given. Good news. It says that angle D is congruent to angle C. So that's going to be a pair of angles. Let's mark that pair of angles. Here they are. So we can just mark it. We don't need to do anything else with it because it's already said angle this is congruent to angle this. So we don't need to do anything else with it. So we've got our given information. We've looked at how to use all of those pieces of given information. So now we are out of givens. We are out of givens. We've used them all. So when we're out of givens, it's time to go to the diagram. And remember, when we're at the diagram, we either look for vertical angles or reflexive property. In this one, hopefully you see which one it is. So I'll pause for a minute, see if you can pick out which one of those is happening and where it's happening. Remember, not just angle B, because they're 2 different angles. Here they are. They're vertical angles. So remember, anytime you're out of information, look for reflexive property. Look for vertical angles. That's why we spent so long training and looking for those. So now, that's a pair of angles. Hey, that's 1, 2, 3 pieces of information. So now I can go on to say that the triangles are congruent. So we're going to go B, D, A. Let's match up B, D, A. B will just match up with B. And then D, well, D, we know angle D matches with angle C. So D should match up with C. That leaves A to match up with E. And what's our method? Well, let's look. How many pairs of angles? 1, 2 pairs of angles. How many pairs of sides? Just the 1 pair of sides. And then is my side included between those 2 angles? No, it's not. Angle, angle, side. Now, usually in our proofs, we've been done, but this is where we're adding that new piece. This is that only new piece that's getting added. Final step. Final step. Because these triangles are congruent, again, this leads to this. because these triangles are congruent, I can now say that A to D is congruent to E to C. Again, let's check that. A to D, last two letters. E to C, last two letters. They match up. And the thing that lets me match them up is CPCTC. Done. So the only new element of that proof is adding on that last step, that very last step. Once you got the triangles congruent, we said that we matched up that last pair of sides. It unlocked any of the pairs of sides. CPCTC would also tell me that angle A matched up with angle E. Last letter matches up with last letter. But the one we were being asked to prove was A to D with E to C. So we said that one. That was our final conclusion, our reason, CPCTC. Now, here's that same proof written out as sentences for those of you that prefer sentences. Same idea. We're given to B as the midpoint of A to E. Well, what does that tell me? It means that it will make the two pieces equal. So that means that A to B is congruent to B to E. There's pair of sides number one. So there's my sentence that explains how the midpoint tells me that the pair of sides is the same. Then we're also given that angle D is congruent to angle C. Not much more to say there. Then we're going to say, here's my vertical angles. Listing them out, ABD, EBC, because vertical angles are congruent. There's my pair of angles. Therefore, the triangles are congruent by angle, angle, side. Since these triangles are congruent, here's my final sentence added on. A to D and E to C must be congruent, and it's CPCTC that lets me say it. So there is my last conclusion. So CPCTC, corresponding parts are congruent, triangles are congruent. After I have the triangles congruent, I can then say my last missing piece has to be the same.